Welcome to the module on the violation of OLS assumptions. This is basically the summing up of all the concepts which are dealt with regard to the violations of the OLS model in terms of a regression exercise. Because this will take care of some of the tests, some of the detections, and as well as the remedial measures which were conducted in case of the regression exercises. So in this particular module, these practical implications will be discussed along with a kind of a revisiting some of the basic concepts of the violations which are being done. In this particular discussions, it is basically addressing the classical assumptions of ordinary least square regression model, which is basically the accepted model for estimating the linear parameters of a regression model. So whenever we are dealing with any kind of regression exercise in the OLS model, we are dealing with a relationship between the dependent and the independent variables along with the presence of an error term which we'll consider as a stochastic random term. So this error term basically encompasses all the other factors which are not included within the independent variables, but they are treated as the omitted variables and how they can affect the dependent variables also. Hence, this error term is a probabilistic term which has to satisfy certain assumptions in order to estimate the model in a more reliable and efficient manner. So whenever we consider the validity of the OLS estimator, we make it very clear that the inference or the reliability analysis that can be done are based on a set of OLS assumptions which are known as Gauss-Markov assumptions. So among the OLS assumptions, we take up the first one, which is linearity. So this linearity basically explains that there is a linear relationship between the dependent variable that is y and the independent variable that is x, as if the fit would be always the equation of a straight line with an intercept term and a slope coefficient. The second assumption that comes up under OLS is the strict exogeneity. It means that the error term will have basically the zero mean. So whenever we are considering the error term, then on average, the value of the error term will be 0, or in a way, the error term is a random variable, so expectation of that error term will become 0 when we consider all the sample observations together. The third assumption says that in a multiple regression model, whenever we are including more than one independent variables, they should not be correlated with each other. Hence, there should not be any problem of multicollinearity. So, any such kind of problem will make the OLS estimators to be inefficient. Hence, one of the OLS assumption is no perfect multicollinearity. Moreover, we also have more set of assumptions like the variance of the error term. So whenever we consider the variance of the error term, then across all observations and across all the independent variables, the error term should have a constant variance. That is what we say homoscedasticity. Then we have the problem of the endogeneity. So it may happen that in any regression model, the independent variable is correlated with the error term. For example, we are doing a wage education model. That means wage is the dependent variable and education of the respondent is the independent variable. But there may be some factors in the error term like the parental education or about the educational institution in the close proximity of the resident of the respondent. So in all these cases, there may be some kind of relationship. So if such kind of relationship comes up between the error term and the explanatory variable or independent variable, then we have the problem of endogeneity. And if this becomes very clear or acute, then OLS assumption or the OLS regression model cannot be applied. Next assumption is very much important because in all this kind of inference testing, we rely on a distribution which has an underlying normal distribution. So whether we go for the t-test or any kind of testing procedures, the underlying distribution is normal. That means a symmetric distribution actually. So for all these purposes, we assume that there should be a normality assumption which should have a zero mean and a constant variance. So in all these cases, we can see that zero mean and constant variance must be there as far as the normality assumption is concerned. If we look at the large sample size, then also we can see that from the large sample size, which is n greater than 30, then only the regression model under OLS can be applied. So all these type of assumptions are very much required for estimating the unknown parameters of the population regression model. But any kind of violations will make the OLS estimators to be inefficient or biased, and that is what we are going to look into, the individual violations of these assumptions regarding their detection, regarding their test, and finally what can be the remedial measures to avoid such kind of estimation process. Now we come up to the violations of the normal OLS assumptions. So one by one we will take up the violations, what do they mean, and then we will take them in elaborate manner to explain the detection and the test and the associated remedial measures that can be suggested. The first violation refers to non-linearity. As in the OLS assumption, it is always clear that the relationship will be always like a straight line, but it may so happen that the OLS estimates are not capturing the true relationship. So maybe we take some kind of transformation, we may square the independent variables, or we may take a quadratic form, or any kind of transformation that will make either a S-shaped curve or any kind of cumulative curve which will follow a nonlinear transformation. So under that assumption, we cannot apply the ordinary least square regression model. Second one is the violation of the strict exogeneity. So whenever we are considering that there is a relationship between the error term and the independent variables, then the OLS estimates will be biased. So as a result of that, the independent variables and the error term will be correlated with each other. And if such happens, then definitely the endogeneity assumption is violated. So we need to take up a method or a estimation procedure which will capture the problem of endogeneity, like the generalized method of mean square error or any kind of GMM method which is more advanced compared to the OLS method. Next, we have the problem of perfect multicollinearity. So if it is seen that the independent variables have a strong degree of correlation between them, so it may happen in any multiple regression model when we are looking at economic growth as a dependent variable and depends upon a series of factors from different dimensions. Say from finance, we take the banking parameters, from infrastructure, we take the road, the railways, even from the internet connectivities, we take the broadband connectivity or the mobile users. So many factors can come up as independent variables. So it may so happen that any two factors or three factors are strongly correlated among them. So if such happens, then the OLS estimation cannot be computed. We have to take some kind of suggestions or remedial steps to avoid the problem of perfect multicollinearity. Moreover, one of the very strong violation of the OLS assumption is that variance is not constant. Variance is actually changing with the number of observations, and also it is changing with the number of independent variables. That means as we are increasing the number of independent variables, variance becomes inflated, as well as increasing the number of observations, variance also increases. So if such happens, then the OLS estimation procedure will be not appropriate. We have to think either weighted least square or any other adjusted variance procedure. That means where the variance changes can be accommodated, any such estimation procedure may come up. This happens when we deal with a kind of a cross-sectional data due to the variation in income or variation in other criteria. This problem may crop up. Another violation is endogeneity, which occurs whenever we are dealing with a panel data or any such kind of measurement error comes in where the independent variable and the error term are strongly correlated. Non-normality is also one of the most important violation of the assumption. That means whenever we are going for inference testing or any kind of testing procedures, then we cannot go on applying the t-test or any kind of test which has a normal distribution at the back end, because this is the violation of the normality assumption will take place, and as a matter of fact we can say that the entire model has to be estimated using some kind of distribution which does not follow normal distribution. Small sample size sometimes can come up because of the paucity of data. So suppose the data cannot be collected beyond a certain limit and thereby some kind of compromise is done. Under that situation, OLS estimator may be compromised, but there should be always some alternative estimation techniques. So these are some of the violations of these OLS assumptions which are mentioned as a direct violation of the methods which are required for start with the OLS model. Now it is important to go for a more elaboration of each of the violations, particularly in terms of the diagnostic test, in terms of the detection, and also in terms of the remedial measures that can be suggested. This brings in the first violation, that is the non-linearity. So whenever we are considering the assumption of non-linearity, it means that the relationship between the y and x is curved, or it has some kind of exponential relationship, or it can be square of any variables, or there can be some interaction effects like the product of two variables like x1, x2 taken together. So all such transformations will make OLS estimation procedure invalid or inappropriate. So it will be very much important to detect the nature of the nonlinearity and also to go for a valid inference. So nonlinearity clearly says that it cannot be effectively approximated by a linear equation. And as a result of that, it will have some kind of changes, for example, additive or proportional, because it cannot be done in a simple manner as we do in a simple regression model, where we say that there is a proportional change in the dependent variable due to the change in the independent variable and so on. But this kind of simplistic inferences cannot be drawn if the variables follow a kind of a curve or exponential or any other nonlinear functions. This brings into the detection of this nonlinearity. So the detection is actually challenging, but there are some methods to detect this problem of nonlinearity. The very first detection in any econometric model is visual plot, that is plotting the data. So whenever we are plotting the data, particularly plotting the relationship between the dependent and the independent variables, we get some scatter plots, that is the scatter diagram. So the scattered plots will give us some kind of indication that whether the relationship is a linear or nonlinear. If we get an increasing trend or a decreasing trend, and that is straight line, then definitely it calls for a linear relationship. But if we get a curved or S-shaped or any kind of change, particularly the slope is changing, then definitely we will go for a nonlinear estimation. So it can be some clusters, some irregularities, so some kind of changes in the straight line. All these things are the indications that linear assumption cannot be applied. Residual plot can also be done in the same way. That means we are doing a regression, particularly we start with a linear regression and then we go for a residual plot. So if the residual plot display a clear pattern, that means either the residual plot is having a kind of a pattern, whether it's increasing or decreasing, then definitely this is a symbol of linearity, but it's violation. So plotting the residuals can also help us in identifying the nonlinearities. Another important detection refers to the polynomial regression. So in the context of a functional relationship, it may so happen that the independent variables are taken in the squared or the cubic forms. For example, in the cost function, you have both the squared terms and the cubic terms. So in such case, it is very evident that the estimation procedure must incorporate the nonlinearity in terms of the relationship between the two variables. And this basically captures wherever we go for the model fitting, the nonlinearity would be always better compared to any kind of linear model. Moreover, some kind of test can be conducted for the confirmatory analysis. For example, the common test is Ramsey test, which means that we are regressing the cubic or the squared terms on the original independent variables. And if the coefficients are statistically significant in terms of the cubic or the squared terms, then definitely the nonlinearity comes in. Another important test in this regard can be the Brosh-Pagan test, which will also say that the parameters are nonlinear if the squared residuals are taken up, which have a correlation with the independent variables. That means Prosh-Pagan test is the famous test for capturing heteroscedasticity, but also it can be applied for any kind of nonlinear relationship among the parameters if we find out that the squared and the cubic terms are coming in. Moreover, we have another test which is considered as the Harvey-Collier test, which says that the sum of the squared residuals from the linear regression is basically taken up. So in such case, if the alternative hypothesis is accepted, then it indicates the nonlinearity. So in all these tests, we have seen that the classical OLS assumptions are strictly violated, and thereby we need to suggest some kind of estimation procedures which provide a better fit or the goodness of fit than the normal OLS model. And as a result of that, careful examination of the data is very much required. Another important violation comes in is the violation of strict exogeneity. This is basically coming up when we are actually addressing the problem of endogeneity in the model. So violation of strict and exogeneity means where the error is correlated with the independent variables. So as a result of that, OLS estimates will be biased, and also in the presence of endogeneity, they will be providing some kind of standard errors which are actually invalid. And if such kind of consequences crop up, then the inference or the statistical policy making or the inference making will become error. So strict endogeneity means that the error term has an expected value of 0 conditional on the independent variables. That means no relationship between the error term and the independent variables. But if the violation takes place, then this correlation coefficient has to be taken care of. This basically comes in to some of the detections regarding the violation. The first important detection can come up from the theoretical knowledge or the theoretical domain, because we can take up some kind of examples from our econometric analysis, for example, the FDI growth relationship or age and wage relationship or any such kind of relationship where there is a two-way relation between the independent and the dependent variables. That is what we say the feedback relationship. It may also happen that the omitted variables are very much scattered and they are correlated with the independent variables. For example, wage education analysis, where there are many variables within the error term like parental education and also the education environment of the family, as well as the educational institutions about the distance from their residences. So all these things, factors may not be the independent variables, but they are under omitted variables, but they may be correlated with the X. So in all these cases, we can see that these are the theoretical understanding from the literature review or from any other research papers. These are the theoretical understanding that what can be the potential source of endogeneity. So before doing any kind of statistical testing, just from the theoretical knowledge, one can say that there is a source of endogeneity in such kind of estimation exercise. For example, the growth model always have this problem. Now the statistical testing is the residual plotting. So when we plot the residuals, then we can see that some patterns are being revealed. So these patterns basically exhibit a systematic pattern. That means either there is a trend which is increasing or which is alternate patterns in terms of ups and downs. So all these are some of the indications that endogeneity problem is existing and strict exogeneity is being violated. Another important method that comes in this regard is the instrumental variables. Because if such kind of patterns are observed, then the ordinary least square estimation will never be valid, so you have to think of some other method of estimation. So that is what we mean by the instrumental variable method, which means we have to add some instruments which is correlated with the endogenous independent variables but not with the error term. So for example, we have the wage education model where the education of the respondent is the independent variable and age of the respondents is also another independent variable, and the dependent variable is the wage of the respondent. So it may happen that there is a strict endogeneity problem here because error term is correlated with the education of the individual. That means in terms of parent or any other factor. So we can take an instrument, for example, the residence or the place of the respondent and its distance from the school. So if we take this variable, that can act as an instrument for the education variable. So such kind of instrument has to be actually identified from the literature or from the domain knowledge, but the instrument selection also needs a test. Whether the instruments are appropriate or not, that testing is needed. And that is why there is a condition that the instrument should not be correlated with the error term. Otherwise, there will be no improvement in the estimation exercise. So some test we can go for. The first test that is being suggested is Durbin-Wu-Hausmann test, which means that the test estimates the results from the OLS regression, and if there is an endogeneity, then the OLS estimates will be inconsistent and instrumental variables will be consistent. So that means this test will clearly tell us whether the endogeneity problem is there or not. That means the null hypothesis says that no correlation between the error and the independent variables, but the alternative is just the opposite. So if this test is statistically significant, then endogeneity is a severe problem. Another is Hausmann test, which also takes care of, because when we do a panel regression, basically we are doing an instrumental variable regression. So here also we talk about a fixed effect and a random effect. So if the two estimators are statistically significant, then endogeneity is there. There are other tests which is called the Sargan-Hansen test or the Anderson-Rubin test. Sargan test is the most famous and the most popular and the convenient test which is conducted for the appropriateness of the instruments selected. So Sargan test is being conducted, and if the null hypothesis gets accepted, then definitely we can say that the instruments are valid and the endogeneity problem is accommodated. So in terms of the detection and the testing, most importantly the expert judgment and the subject knowledge is important, to understand how endogeneity is originating and what can be the instruments which can be selected to address the problem of endogeneity, because this requires a thorough understanding as well as the knowledge of the existing literatures which are there in such kind of empirical exercises. Because in majority of the real life data, endogeneity is always a problem where OLS can never be applied. Another important violation that takes place is the perfect multicollinearity. So whenever we are considering a perfect multicollinearity, which is very much evident in a multiple regression model, we see that one or more independent variables are correlated. So that means we can say that the individual impact of the independent variables cannot be captured, and as a result, independent variables follow a linear combination such that one variable can be expressed as the linear combination of the other. So this will definitely lead to the impossible impact on the dependent variable. This will make the numerical instability and inference cannot be drawn. So perfect multicollinearity means that there is basically a linear correlation among the independent variables, and it's impossible to estimate the individual effect, and thereby violation occurs in the regression model. In this regard, we have some kind of test or some kind of detections. The very basic detection is under the descriptive statistics, which is computing the correlation matrix, because the correlation matrix will be computed for the independent variables only. And we know that the correlation coefficient lies between -1 and +1, and if the value is more than 50% and near to 1, that means the variables are strongly correlated and they cannot be taken up together in the estimation exercise. So whenever we look at the correlation matrix, then from the estimated coefficients of the correlation coefficients, we can make out a conclusion how the multicollinearity becomes an issue. Another important test that is always done is called the variance inflation factor. That means it is the ratio of the variable's coefficient estimate to the variance of the coefficient estimate. That means variance of the variable's coefficient estimate to the variance of the coefficient estimate that is being conducted. So if it is extremely high, actually greater than 5 or 10, this indicates there is a strong presence of multicollinearity. So VIF will be computed for each of the independent variables individually, and that value should be less than 5 if we want to go for OLS model. Otherwise, we have to make a commitment that we cannot take all those correlated variables together. We have to take one at a time, and then only the severity can be affected. There are some tests to conduct or to detect the presence of multicollinearity. The first test is the condition number or the CN. So what is this condition number? It is basically making it clear that one variable can be expressed as a linear combination of the others. So in such case, square root can be taken up as the ratio of eigenvalues which is highest to the lowest. That means if we take the square root of the highest and the square root of the lowest, then we can make a condition. So if this is greater than 30, then definitely there is a severity of the problem or high degree of multicollinearity. That means if the CN number is greater than 30. Eigenvalue test. So whenever we consider the eigenvalue test, it means that the variance explained by each eigenvector in the correlation matrix. That means if there is a perfect multicollinearity, then one or more eigenvalues will be close to 0. That means they are basically linearly dependent. They are not linearly independent. So as a result of that, low eigenvalues can be detected by the principal component analysis or by examining the eigenvalues directly. That means in order to go for a multicollinearity, one can go for a principal component analysis and one can take up the list of the eigenvalues which are generated. If these values are very low, then it means that the problem of multicollinearity is there. Another important fact that crops up in this manner is the tolerance. That means this is the proportion of the variance of the independent variable. So if the tolerance is close to 1, definitely the severity is there. If it's close to 0, then it is indicating the high multicollinearity, and as a result of that we can say that OLS method cannot be applied. So in such cases, these are the confirmatory tests which can be conducted to make the presence of the multicollinearity problem. Another one which comes up from the theoretical knowledge is the ridge regression. That means we are introducing a new term and we want to do the regression, that is by shrinking the regression, and the problem can be detected using this. But this test is actually more applicable in the theory, but in the practical exercise we go for the correlation matrix, the variance inflation factor, the condition number, and also we go for the visual plotting. So if the multicollinearity is detected, then it is very much necessary that to obtain the meaningful and the reliable regression models, we have to remove them or we have to combine them into composite variables. That can be done by creating an index among the variables which are correlated, or we can eliminate the presence by taking the variables one at a time. Then only we can say that the estimates will become more efficient and unbiased. Otherwise, this problem will be a perennial problem under a multiple regression model, because in a multiple regression model, many independent variables are considered, so there is a high degree of correlation among them. Another important violation of the OLS assumption, which is actually one of the major violations of the error term, is the non-constant variance, and that is called heteroscedasticity. Edasticity means variance, hetero means changing. So whenever we consider heteroscedasticity, we mean that the variance keeps on changing with the number of observations, it's getting high, or with the number of independent variables. So as a result of this, it varies systematically, and this violation will become very acute and will lead to inefficient and biased estimates. So standard errors also will become incorrect, and no inference can be drawn if such problem is detected. So you have to think of any estimation procedure which accommodates the problem of heteroscedasticity. So first of all, we go for the detection. Like the other violations, everywhere the first detection would be by plotting the data. So what we can do, we can plot the residual series, because it is the variance of the error term which is changing. So we find out the scatter plot of the residual series, and we find out the spread of the residual. So if there is a fan-like or a funnel-like shape which keeps on changing or which follows a certain pattern, then definitely heteroscedasticity is very much there. Another important confirmatory test that is being always conducted is the White test and the Brosh-Pagan test. So when we call the white test, it means that this is a very, very popular diagnostic test. So what is done? It is regressing the squared residuals on the independent variables and their squares. That means the residual series is obtained after the first regression. In the second step of the regression, square of the residuals is taken, suppose ei square, which is regressed on the xi's and also on their respective squares. So if the null hypothesis gets rejected, that means there is no change in the variance, then definitely the problem of heteroscedasticity comes in. Another confirmatory test, which will be robustness test of white test, is the Brosh-Pagan test. So what is being done? It follows a chi-square distribution. It takes the squared residuals of the independent variables and the presence of heteroscedasticity comes in. So this is another important test to signify. And another test which is being conducted basically by truncating the data set, which is called the Goldfeld-Quant test. But in the Goldfeld-Quant test, one of the disadvantages is this: it divides the data set into two segments and it conducts the test on the different subsets of the data so that the variance of each subset is significantly differing from each other. That means the first subset and the second subset, whether the variance is differing from each other. Another important test which is conducted basically to accommodate the problem is the robust standard error. Because whenever we go for estimation exercise, then in today's, this can be done in any econometric software where they will ask for whether the standard errors will be robust or non-robust. So if we select them to be robust, then they are heteroscedasticity adjusted errors. And in that case, it may happen that the problem is accommodated. So we go for a robust heteroscedasticity standard errors so that it takes care of the changing variance. Another important method of estimation can be weighted least square, which means that the weighted observations is proportional to the variance of the error term. That means as the weights are rising, the variance of the error term will come down. There is an inverse relationship. So this is very much popular test. This is also comes under the generalized least square, that is called the GLS, but weighted least square can be there where the weights will be assigned to the squared residuals of the error term. Transformation can also help in the process, but that is very rare, where we can make a log transformation, and by taking the log, the spread of the variable is reduced. That means the variance is taken care of, and as a result of that, heteroscedasticity can come down. Generalized least square is one of the most popular method, which basically takes into account both the problems, not only the heteroscedasticity but also the autocorrelation, and as a result of that, it will make it more clear when we go for a heteroscedasticity adjusted error term. So based on all these tests, we can signify that whenever we are addressing the problem of this heteroscedasticity, it's very clear how can the problem can be accommodated without going for OLS, because any kind of OLS will be inappropriate. Another violation that crops up in this regard is endogeneity. Endogeneity is basically what is actually explained by the violation of strict exogeneity, which occurs whenever the error and the independent variables are related. So this is because omitted variables or measurement error or the two models are interconnected. For example, when we do a simultaneous equation modeling, then the first one will be an identity, for example, from macro, y is equal to c plus I plus g, and the second one is a consumption function. But consumption is a part of that identity, so these two equations are having a feedback mechanism. They are related on one another. So in such cases, we have to apply some instrumental variable approach, or we have to apply some other methods of estimation other than OLS. This basically can come up from the subject matter of the knowledge, as we can see in terms of the detection, because we have to take care of some examples where this causality happens. Causality means two-way relationship, like growth and capital flows as a causal relationship, both ways they can affect each other. Export and exchange rate can have a causal relationship. So all these things are basically coming up from the theoretical understanding. and empirical treatment would be to addressing the problem of causality. Residual analysis can be done in this way by plotting the residuals, and if we get any pattern, then definitely the endogeneity problem is very much there. Instrumental variable approach can come up because this is one of the most popular and one of the most appropriate estimation procedure which can take care of this problem. Based on this, some confirmatory tests are being suggested. One of them is definitely the Hoshman test, because this is done in a case of a panel regression when initially we consider that there is some fixed effect in this panel regression. That means some of the components of the intercept which is independent of time, but they varies across cross section. And another one can come up, that is in terms of the random effect model, where we can see that this random effect model means where the variables are changing in terms of the slope, but they are time dependent, and so we have to select either the fixed or the random. And this selection can be done based on the Hoshman test, that is the regularization of them. Based on this, we also have the Darboux-Hoshman test, which means it will give some potentially endogenous variables, and if it is consistent, then the problem of endogeneity comes in. Sargan test is also comes as one of the most appropriate tests regarding the selection of instruments, and then endogeneity is a concern if the null hypothesis is not rejected. Over-identification or under-identification, that means this appears under simultaneous equation modeling. So it may happen that over-identification can be caused when more instruments are necessary or less instruments are necessary. So this will be done by a test over ID, and based on that we can give a comment or we can conclude whether the endogeneity problem is there or not. Another important violation which has come up under the OLS is the distribution of the error term is not bell-shaped. That means it is skewed. So this can happen whenever we plot the stock data, let's say the stock price data, we can observe some clustering of observations, or we may plot any kind of time series data over a longer period of time or a longer time span where there can be some skewed distribution. And in all these cases, OLS will be always unbiased and inconsistent. So we cannot rely on the hypothesis testing, nor we can rely on the confidence intervals. So we can take care of the skewness or the kurtosis or the presence of the outliers. So these are some of the indications that normality assumption cannot be affected. So in such cases, the very basic test is just to go for descriptive analysis and to go for exploratory data analysis like histogram or density plot. Because when we go for the histogram, then the residual plot will tell us whether the bell-shaped curve comes in or not. Then we can go for a normal probability plot where we can get some kind of deviation from a straight line, so it's a departure from the normality. Apart from that, we can conduct the Jagd-Balmer test, which will consider the skewness and the kurtosis. So in a normal distribution, mean, median, mode are actually equal or they're approximately closer. But if we observe mean greater than median, greater than mode, or just the reverse, then it's an indication of skewness, either positively or negatively, but OLS cannot be applied under such situation. So in order to do that, we have some test procedures to detect the problem of non-normality. One of them is Jagd-Balmer test, which means that it will follow the null hypothesis of normality, but if the p-value is actually greater than 0.05, but if it's less than, then it's a departure. Then the Smirnov test, which is also considered because it's a test statistic which is done on a cumulative distribution function. That means it takes a CDF, a nonlinear pattern, and if it is a violation, if the null hypothesis gets rejected. Apart from that, it is also important that some of the departures in terms of the normality assumption due to the central limit theorem, because central limit theorem says zero mean and constant variance, but this may not be maintained in all the samples. So if the violations are detected, then we need to go for any other regressive procedure which will be non-parametric, or you have to transform the variables and you have to take regard of that. That will make the non-normality to come up. Now another important violation is violation of the small sample size assumption is in classical OLS, which we see that the sample size is small compared to number of independent variables. This is a very significant problem, because if the number of independent variables becomes more than the number of observations, then the degrees of freedom are lost. And if the degrees of freedom are lost, then the inference testing procedures will be overall invalid or inappropriate. So under such cases, there will be challenging to address or to proceed with such kind of data set. So basically the first important detection is that when we will go for the fall or the reduction in the degrees of freedom, and that will make the estimates to be imprecise or invalid. Second important point is variability of the estimates. That means it may happen that the estimated coefficients are not significant, and this can be due to the number of explanatory variables are sufficiently more than the number of observations. That means if the number of observations is 50 and number of explanatory variables are more than 30, so the difference is very less. So this will make the variability of the estimate to be questionable or contradictory. So statistical inference drawing would be a clear problem under such situations when we are basically going for a small sample size compared to number of independent variables which are taken. So we can go for some test. One of the most important tests is the robust standard error, because we can take care of that so that it can estimate even there is a small sample. We can go for some kind of estimation procedures, or the data set can be ordered. Either we create an index or we go for a bootstrapping where some of the simulations are being done and the sample is adjusted, or we can go for some kind of properties which will be applying the statistical inferences. So this way we can take care of this small sample size. Another important point that comes up from this small sample size is sensitivity analysis. Sensitivity analysis means after the estimation is being done, we can run some robust tests to see whether the results are changing with the inclusion of any new variable or deletion of a variable, because deletion is more important because number of variables are more. So if any such kind of changes occur in the estimation results, then definitely the result is non-robust. So we cannot continue with such kind of result. So basically the most important way out for this would be to go for a maximum likelihood estimation or Bayesian approach rather than the OLS estimation, because such kind of methods like the MLE estimation can take care of the small sample data. So in this particular module, we'll come up with some kind of violations of the OLS assumptions, not only in terms of the detection or the test, but also we are suggesting some alternative methods or methodologies to combat with the problem. Because the OLS assumptions followed from the Gauss-Markov theorem, which are reliable and they provide the accurate and the valid estimates. But if we detect any kind of OLS assumptions such as multicollinearity, heteroscedasticity, endogeneity, then all these are actually affecting the reliability of the estimates, so that the weighted least square instrumental variable regression or maximum likelihood estimation, these are some of the suggestions that can be done to take care of this problem. Because we have to first understand the source of the violation, there should be a theoretical knowledge to support it, and then only we can go for the appropriate statistical testing for a proper estimation exercise. So that is how we can see that here the most important criteria that crops up is how can we deal with the real life data which will tell us the violations from the OLS, and how can we deal with such kind of violations. That means we have to think of any advanced econometric methodology which can take care of the violations, and they can able to provide an accurate estimate of the unknown parameters.